Brace yourselves for a cosmic cataclysm of unprecedented proportions. Betelgeuse, the red giant star poised on the edge of our galaxy, is sending ominous signals through the universe. Using the James Webb Space Telescope, astronomers have uncovered something profoundly unsettling about this colossal celestial body. As renowned astrophysicist Brian Cox issues a grave warning, the question looms: are we on the precipice of witnessing a catastrophic supernova explosion that could forever change the night sky as we know it? Let's dive in. In the grand tapestry of the cosmos where stars are born, live, and die in spectacular fashion, one star has recently captured the imagination and concern of astronomers and the public alike. This star is Betelgeuse, a red supergiant of immense proportions and age situated conspicuously in the constellation Orion. Its distinctive reddish hue and variable brightness have long been a source of intrigue, but recent developments have intensified interest in this celestial giant. As we explore the nature of Betelgeuse, we find ourselves on the cusp of a potentially monumental event in the life cycle of this star. But what could these changes in Betelgeuse signify? Are we witnessing the prelude to a cosmic spectacle of unimaginable scale? Betelgeuse, approximately 764 times larger than our Sun, is a stellar behemoth. Its colossal size is almost beyond human comprehension. Imagine a star so vast that were it to replace our Sun, its surface would extend beyond the orbit of Mars, engulfing Mercury, Venus, Earth, and Mars in its stellar embrace. This incredible size is not just a testament to Betelgeuse's physical attributes, but also speaks to its stage in the stellar life cycle. As a red supergiant, Betelgeuse is in the twilight of its existence, a phase characterized by expansion and cooling following a life spent fusing hydrogen into helium in its core. But what about the age of Betelgeuse? This star, believed to be around 8.8 to 8.5 million years old, is relatively young in human terms but ancient in the context of stellar lifetimes. Its current red supergiant phase is the culmination of millions of years of stellar evolution, a period marked by dramatic changes and processes that have transformed it from a hot blue star to the red giant we see today. The life cycle of stars like Betelgeuse is a story of transformation driven by the relentless forces of nuclear fusion and gravity. Betelgeuse's distinctive reddish hue is another hallmark of its current stage. The red color is a result of its relatively cooler surface temperature compared to other stars like our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's cooler surface registers temperatures around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at wavelengths that give it a red appearance. But this color is not just a visual trait. It provides clues about the star's physical condition and the processes occurring within its vast gaseous expanse. Adding to Betelgeuse's mystique is its historical color change. Ancient Roman and Chinese writings suggest that around 2,000 years ago, Betelgeuse was yellow. It was only in the 9th century that Arabic scholars first described it as red. This color shift over human history is not just a detail in the annals of astronomy but a clue to the star's evolutionary path. The variable brightness of Betelgeuse is another intriguing aspect. It's a semi-regular variable star, which means its light periodically waxes and wanes. This variability is a characteristic dance of luminosity that has fascinated astronomers and sky watchers for centuries. Typically, Betelgeuse undergoes a 400-day cycle along with a longer cycle that stretches about 5 years. These cycles have been documented as far back as 1836 by Sir John Herschel and possibly even earlier in Aboriginal oral traditions. But what makes Betelgeuse truly enigmatic is not just its changing brightness but its irregularity. Unlike many stars that follow a predictable pattern, Betelgeuse occasionally deviates from its rhythmic dimming and brightening, hinting at complex and less understood processes occurring within its colossal form. Recent groundbreaking revelation Betelgeuse captured the attention of astronomers and stargazers worldwide with an unexpected and dramatic change in its appearance, an event now famously known as the Great Dimming. In late 2019, the red supergiant Betelgeuse, one of the brightest stars in the night sky and a prominent feature of the Orion constellation, began to mysteriously dim. The star's dimming was so pronounced that it began losing its luminosity at an average rate of 0.01 magnitudes per day, reaching its lowest brightness in February 2020. Betelgeuse, normally visible to the naked eye even in light-polluted areas, became markedly fainter, a change noticeable even to amateur observers. However, there's one problem with trying to monitor the activities of Betelgeuse: the time paradox. When we look at a star like Betelgeuse, we are not seeing it as it exists in the present but as it was in the past due to the time it takes for light to travel to us. In Betelgeuse's case, at approximately 725 light-years away, the light we perceive today left the star nearly 7 centuries ago. This time lag makes it challenging to predict and monitor sudden changes in a star's behavior as we are essentially peering into its past. The Betelgeuse dimming event served as a reminder of the inherent difficulties in real-time astronomical observations and the limitations of our understanding when dealing with the vast cosmic scales and the time paradox they introduce. The unfolding of Betelgeuse's celestial drama was closely monitored by Andrea Dupree, Associate Director of the Center for Astrophysics at Harvard and Smithsonian, and her team. They utilized Hubble to analyze the behemoth star as part of a 3-year study to monitor variations in Betelgeuse's outer atmosphere. These observations offered a unique insight into the dynamics of a variable star like Betelgeuse, which regularly expands and contracts, causing fluctuations in brightness. Hubble's sensitivity to ultraviolet light allowed the researchers to probe the layers above the star's surface, which were heated partly by the star's turbulent convection cells. Further analysis of the Hubble spectra taken at different points throughout 2019 and 2020 helped in measuring the movement of material in Betelgeuse's outer atmosphere. In particular, the spectra focused on magnesium-2 lines, which are indicative of the star's atmospheric conditions. These observations showed material moving at speeds of about 200,000 miles per hour from the star's surface into its outer atmosphere. This hot, dense material eventually extended millions of miles from Betelgeuse and was the precursor to the dust cloud that led to the star's dimming. Dupree and her team estimated that about twice the normal amount of material from Betelgeuse's southern hemisphere was lost over the 3 months of the outburst. This mass loss was significant, especially considering that Betelgeuse, like all stars, continuously loses mass, albeit at a rate far greater than that of our Sun. The scale of this mass ejection and the subsequent dimming sparked discussions among astronomers about whether this event could be a precursor to a supernova explosion. The proximity of Betelgeuse, about 725 light-years from Earth, adds to the intrigue as any such explosion would be visible from Earth and provide a rare opportunity to observe a supernova up close. Yet the question remains: what does this dimming event portend for Betelgeuse's future? Is it an indicator of an impending supernova or simply a unique episode in the star's long and complex life? Several theories were proposed to explain this sudden change. One prevalent theory suggested a phase in the supernova explosion process, a hypothesis that gained traction due to the common belief that Betelgeuse is nearing the end of its life. Another popular theory implicated dust, possibly from the star itself, obscuring our view. Betelgeuse, like other red supergiants, is known to shed material, and it was thought that this material could form a dust cloud dense enough to dim the star's light from our perspective. A third explanation considered changes in the star's photosphere, the visible surface layer, which could affect its apparent brightness. In-depth analysis using various observational methods helped unravel this mystery. Spectroscopic studies indicated a drop in Betelgeuse's effective temperature, suggesting that the dimming could be due to a large dark spot on the star's surface. This theory was supported by the observation that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming, pointing to significant changes on its surface. In the end, the key to understanding this unusual phenomenon came from humankind's sentinel in outer space, the Hubble Space Telescope. Hubble's observations revealed that the dimming of Betelgeuse was most likely caused by a significant ejection of hot material into space. This material formed a dust cloud that obscured a portion of the star's surface, effectively reducing the amount of light reaching us from Betelgeuse. The dust cloud was believed to have formed from superhot plasma, which erupted from a large convection cell on the star's surface and then moved through its hot atmosphere to the colder outer layers. As it cooled, it formed dust grains, creating a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet light spectroscopic observations, which began in January 2019, were crucial in piecing together the timeline leading up to Betelgeuse's darkening. These observations captured signs of dense, heated material moving through the star's atmosphere in the months preceding the dimming. In December 2019, several ground-based telescopes also observed the star decreasing in brightness, particularly in its southern hemisphere. This material, which was initially more luminous than the star's normal brightness, eventually led to the formation of a dark cloud as it moved outward and cooled. The hypothesis was that this outflowing material and the resulting dark cloud caused the star's sudden dimming. The scale of this event, unprecedented in recent history, captured the attention of astronomers worldwide and sparked a flurry of research and speculation about Betelgeuse's future. For over a century, astronomers have been fascinated by the unique characteristics and behaviors of Betelgeuse. Its proximity to Earth and its massive size make it an ideal candidate for detailed study and observation. But despite our knowledge of the star's physical attributes and its place in the cosmos, much about Betelgeuse remains shrouded in mystery. The recent dimming event added another layer of intrigue to this cosmic enigma. It reminded us of the unpredictability of the universe and the challenges of understanding the complex processes that govern the lives of stars like Betelgeuse. As we await the next chapter in the life of this celestial behemoth, we are left to ponder the significance of its recent dimming and what it may reveal about the star's future. Will it continue to surprise us with its unpredictable behavior, or will it follow a more predictable path toward the end of its life? Whatever the future holds for Betelgeuse, one thing is certain. Its unique characteristics and behaviors will continue to captivate and inspire astronomers and stargazers for generations to come. The recent dimming of Betelgeuse, a red supergiant star in the Orion constellation, has sparked intense speculation and observation among astronomers worldwide. This event, known as the Great Dimming, began in late 2019 when Betelgeuse started to noticeably decrease in brightness, eventually reaching its lowest luminosity in February 2020. This sudden and dramatic change in one of the brightest stars visible from Earth raised questions about the underlying cause and potential implications for Betelgeuse's future. Astronomers and researchers scrambled to gather data using ground-based telescopes and space observatories like the Hubble Space Telescope to monitor the star's behavior during this unprecedented dimming phase. The observations revealed fascinating insights into the complex dynamics occurring within Betelgeuse, shedding light on its volatile nature and evolutionary stage. One of the prevailing theories to explain the dimming of Betelgeuse centered around the ejection of a massive amount of hot material from the star's surface. This material, likely propelled by convective processes deep within the star, formed a dense dust cloud that partially obscured Betelgeuse's luminous output as seen from Earth. The formation of such a dust cloud could explain the observed decrease in brightness over several months, marking a significant event in the star's evolutionary timeline. The dimming of Betelgeuse also prompted discussions about the possibility of it nearing the end of its life cycle. As a red supergiant star, Betelgeuse is already in the late stages of stellar evolution, having exhausted much of its hydrogen fuel and expanded to a size hundreds of times larger than our Sun. These characteristics make it a prime candidate for eventually undergoing a supernova explosion, a spectacular event that, if it were to occur, would be visible from Earth and could provide invaluable insights into the physics of stellar death. However, despite the intrigue surrounding Betelgeuse's recent dimming, astronomers cautioned against jumping to conclusions about an imminent supernova event. Supernova explosions are rare and unpredictable cosmic occurrences, and while Betelgeuse's behavior is fascinating, it does not necessarily indicate an immediate threat of explosion. Instead, the dimming event serves as a reminder of the dynamic and ever-changing nature of stars and the challenges astronomers face in understanding their complex behaviors. The study of Betelgeuse's dimming event also highlighted the importance of continuous observation and data collection in astronomy. Advances in technology, such as the capabilities of the Hubble Space Telescope and ground-based observatories, have allowed astronomers to monitor stars like Betelgeuse with unprecedented detail and precision. These observations provide crucial data points that contribute to our understanding of stellar evolution, variability, and potential catastrophic events like supernovae. Looking forward, astronomers will continue to monitor Betelgeuse and other red supergiant stars to unravel the mysteries of their behavior and evolution. Each observation adds to our knowledge of how stars live and die, shaping our understanding of the universe on both cosmic and human scales. In conclusion, while the dimming of Betelgeuse captured headlines and sparked scientific curiosity, It also underscored the inherent unpredictability of the cosmos. The star's recent behavior invites further study and analysis, offering a window into the tumultuous lives of massive stars and the extraordinary events that shape the universe we inhabit. As technology advances and our observational capabilities improve, we are poised to uncover more secrets of the cosmos and witness phenomena that continue to inspire wonder and awe.